let's talk about the architecture of the blockchain and what makes this different than everything else.
Okay.
When you think about a standard blockchain, blockchains are designed in a very linear format, which is why they call it a chain, right? It's a bunch of data sets in a row that are validating each other front to back.
Correct.
And it's just this line of communication that consistently goes like this and validates itself, right? Now, the interesting thing about blockchain, like you mentioned, Bitcoin was the pinnacle. Now, blockchain, theoretically, this concept has existed far beyond or far before Bitcoin. People have been using distributed ledgers, for different practices long before that. But when you think about what everything that is currently out there is modeled after, it's really almost modeled after antiquated technology. And what I mean by that is, Bitcoin was really formatted in the 2008, 2009 era after the USA market crash. At that time, we were all having iPhone 1s.
Correct.
Now think about the difference between the original iPhone and the iPhone that just came out.
Yeah.
Technology's come a long way. And so to build something or build a foundation off of something that's 15 years old isn't really self-serving in a lot of ways. When we need to look forward, you have quantum mechanics, you have artificial intelligence, you have all these things that have just made leaps and bounds. We need to be able to look at what blockchain is and streamline it for the next century.
Correct.
Right. And so that's where we're different. One of the best analogies that I've ever heard, a gentleman was talking about an airport runway, and consider the blockchain the airport runway. You have information that's coming and going, coming and going, coming and going. But as these networks expand and grow and get more adoption, and keep in mind, I can't remember what the percentage is, but it's like less than 5% of people are currently on blockchain.
Correct.
In some way, shape, or form. Very, very few.
Yeah.
If we really want that to grow into the 50, 60, 70%, that you're going to create a traffic jam. It's going to look like the, highway in California during midday. I mean, just all backed up in information, which is why some of these transactions in these traditional blockchains start to take longer. They start to cost more in gas fees because there's just so much information being crunched in an inefficient manner.
Correct.
Right. So we looked at that as step one of our problem. And so the way that we look at things is very geometrically. Okay. There's a lot of ways that you can construct this, but logic would tell you that the fastest link between 2 points is a straight line.
Yeah.
But if you go back to the theoretical physics of it, Einstein told us that that's not really the case. You could take 2 points and bend space and time and connect them together through a wormhole almost, right? And again, this is not new theories, but it's just being newly implemented into technology that wasn't even available 15 years ago. And so if you look at the architecture of our blockchain, it looks much different. And I have an example here, a visual.
Love if you want to see it. Yeah, definitely. And I think this is interesting. Well, Jake gets this set up is, kind of think of it, guys, blockchain, right? It's a chain. Just think of these links, or like Jake said, a runway. You're going from point A to point B, and you have to go. So it's taking this long runway of information. We all know, people that are crypto enthusiasts, Bitcoin has gotten very slow, and they put some stuff in there to scale it, and they've done some good things, right? Even in Ethereum, they've gotten it down, but it's like you said, antiquated. It's old.
But what would happen if 50% of the population all of a sudden jumped on it?
We're at 4%. So now imagine we try to scale to 50%. It's gonna
crash the system.
It's gonna crash the system, right? And we always talk about, real quick, because I know we always talk about blockchain. We talk about the slowness and of Bitcoin, and then how expensive Ethereum got over the last couple of years as the NFT space started to grow. But then, people are always talking about, cryptocurrencies being a payment solution, but then you have Visa, MasterCard, they process
a lot quicker,
right? And so you're trying to say, well, why would I go from something that processes 100x over here to something that's 1x? And yeah, it's a little bit more inexpensive. In some cases, it was getting more expensive, but it just wasn't a solution at the time, right? So I think kind of the solution that I saw yesterday is that this, as it grows, gets better. I'll leave it at that for your example.
Yeah. And so, okay, where we look at this differently, and it's hard to illustrate really unless you kind of see it in action, which you guys got a little bit of a sneak peek, and we'll be releasing some of that more and more as time goes on. But this is just kind of a little maybe
Visual.
corny visual.
Yeah.
Yeah. But this right here is just a black box. Now, can you see what's inside this black box? No.
Nope.
Okay. Now, this is in essence what crypto kind of started out as. It had a lot of sovereignty and anonymity behind it,
Correct.
right?
Yeah.
Through these wallets that were numbered and not named. You could transact, with people one-on-one, peer-to-peer.
From my wallet to your wallet, and then it goes into my wallet. You can see into it on the ledger, but unless you knew what the address was.
But that's the other thing is what's in your wallet is really just a representation of what's happening on the actual chain.
Correct.
Right.
Yeah.
And all the information stored there in a distributed format. So this is our version, and we'll call it a wallet for now, but it really doesn't function the same as a wallet. It's more of a container.
Okay.
And we'll come up with some clever name to do it. We're tossing around a couple different things.
Okay.
But contained within this is its own separate blockchain of transactions that are just mined just completely with it outside the realm of the blockchain, right? When I open this, all of the data points, instead of being linear, are actually more geometric in the way that they operate. Okay. And so just like the illustration that we gave about the 2 points, instead of having to go from this point and connect and validate all the way, you can just close it in and open it back up.
So as you close it in, it gets closer, transact, and then it expands back out.
Yep. And so everybody's pocket has its own blockchain within it that is then connected to a larger system of blockchain. It's a blockchain within a blockchain. It's a really new way to think about how blockchain works. But what this does is it allows us to transmit an unbelievable amount of data relatively easy. Think of it like a mesh network, or think of it like a hive. It falls really under more of that category than it does your traditional start to finish linear
blockchain
system.
Yeah.
And what that does is it makes the scalability unbelievable. The more we grow, the more of this that's going on. Every time you add a new wallet, every time you add a new point, you're adding to this geometric, almost breathing, living organism of a blockchain, right?
Yeah.
And that's going to allow us, again, with what we're trying to do with the physical side of things and all of the data that's being transmitted from every different part of the world, all being collected and distributed evenly, really streamlined, really real time, and all of that. So we were talking about comparing it, right?
Yeah.
So if you Google, layer 1 comparisons or this or that, you can come up with, there's really only about a handful
of layer 1
of layer 1s that are mainstream and legitimate.
And let's talk about that for just 1 second, right? Having a layer 1 blockchain in and of itself is a huge feat. Even if it was one of these old antiquated ones with just old technology, right? There's very few out there, right? We could probably, like you said, on 2 hands, we could probably count the legitimate ones. Now, I'll let you continue. I just wanted to say, guys, to understand the importance of actually DEBT having its own layer 1 blockchain.
It's significant.
Yeah.
And especially when you compare the significance of that with the significance of our growth.
Yeah.
And then you compare that to the significance of just our model and how different it is. It really is going to give us an opportunity to present to the world a different alternative.
Correct.
Okay. So in looking at the transaction speed, the cost, and all of that, I just pulled this off the internet, so I'm not I can't validate whether this is accurate information or not, but it says typically a Binance Smart Chain can process about 100 transactions a second. Okay. If you get into some of the newer technologies like Tron, you're up to about 1,000 transactions a second.
Okay.
Now, Solana kind of broke the mold and created their own version of how they do transactions, and they're up to about 65,000 transactions a second. It's significantly faster, right? Now, obviously, we have only been able to do this in a test module,
so there's some caveats here, right? For this is testing data.
Yeah. Because we really don't know, and you'll understand this in a second when we talk about how this thing is expanding and the difference. It's hard for us to really pinpoint it. But in a relatively small testing environment with the amount of nodes that are running, contributing to the computing power, we've been able to hit in excess of 500,000 transactions a second.
Wow.
I mean, almost 10 times what our next best option is.
Correct. So I want you guys to hear that again real quick. 500,000 transactions per second.
Yes.
So that's absolutely amazing, guys.
It's significant.
It's significantly faster than any other blockchain that's currently out there. Obviously, with the caveat that this is test data. But as Jake was showing, the representation of the geometry of the blockchain no longer being linear but geometric, it allows us to compute and transact a lot quicker. So that's what I want you guys to understand. As this, and I'll just pull this out real quick. So as this thing grows, from what I understand, as this grows, right, it gets bigger and bigger and bigger. And then there's these inside of another bigger blockchain. As it grows and contracts, the information, the data is able to actually speed up instead of slow down.
Yeah.
Because it no longer has to go from point A to point B. It could go from point A to point B,
or AZ
or Z or anywhere, and really get to where it needs to really quickly. So 500,000 transactions per second.
Now, if we look at the other measuring things, you look at transaction fee, right? Now, obviously, the ball's in our court here. So we're going to make sure that the transaction fee is comparable to anything else that's out there and try to undercut anything out there. But I know that there's a few layer one blockchains that promote free. We don't want to do that because we're capitalists, right?
Correct.
We want to build an ecosystem that's thriving. And so there needs to be something there, but we want to make it very affordable in the long run.
Well, and then so real quick, just so people can understand this, does that mean when we move off of the Binance Smart Chain, where we currently need to have, BNB in our wallet, when we move over to this debt chain, what do we need to have in our wallet to transact? Debt. And that debt, and I want to clarify this, just a little bit of education. So when you have a crypto on a layer 2, it's called a token.
Correct.
Right. And when you have it on a layer 1, like Bitcoin's a layer 1, Ethereum's a layer 1, debt at this point would be a layer 1, or BNB is a layer 1, right? They're called coins. So this is just to get you guys educated a little bit, is when you hear, the term coin thrown around, debt coin, what's the difference between debt coin and debt token? There is no difference. One is just listed. One is it's a layer 2 because right now we're built off of Binance. We're on Binance. Once we move over to our layer 1, debt token is debt coin. Debt coin then becomes the gas for transactions
of any project that's on the debt chain.
Of any project that is on the debt chain. So
Aluminum, Explorer, Grow, Blocks, all of the ones that we currently have. And more importantly, and we'll get to this in a second, all the future projects that are on will have to use debt as the gas.
Correct. So which
is also why debt is built differently than the other tokens. And a lot of people have asked us, well, why do you play around with so many different tokenomics, right?
Yeah.
Well, debt was designed for this in mind. That's why there's only 50 million in circulation. That's why there isn't a deflationary nature to the debt token. And that's why there's currently no gas fee to move it.
Correct.